I'm Jayan Kim, team leader of ROVATA. We designed a rover with passive suspensions using a spring damper device. The suspensions work independently in order to make flexible motion without interference between wheels. And the rover wheels were designed as a rugged type of wheel in order to broaden the contact area between wheel and ground. Also, the bobar linkage structure was considered because it helped the wheel to steadily keep the wheel traction. The rover traverses compressed terrains safely and stably. In an experimental over-vertical drop at about 1 meter high, the rover flexibly got over the obstacle as well. The rover is controlled using long-distance remote joystick with visual information of cameras. And the wheel motor has enough torque. Exactly maximum torque is 25 Nm. So the rover can run a steep downhill and uphill without any problem. A robot hand should grab thin or heavy objects, such as hammer, wrench, and screwdriver. The fingers were fabricated as the sawtooth design, which is able to grab complex objects. We control the robot arm using a wireless remote joystick with visual information from a camera mounted on the robot hand. The robot hand catches the hammer and the robot arm transfers the hammer to the top of the rubber body. And we used a single link to connect each joint, and we designed a light planetary gearbox to have more torque, because the robot arm should lift a weight of 5 kilograms. The robot arm has 6 joints which make dexterous motion. Thereby the indifector can be approached to a desired point without movement of the rover. And the robot hand grabbed the ball valve and turned it, although the valve was located on the 2 times higher place than the rover. We used the devices as the onboard sensing to investigate Martian soil. To dig 5 cm deep hole, an auger drill is used, and then a temperature humidity sensor checks the condition of soil. If the soil is worth to examine more accurately and precisely, the sampler will collect the soil in order to return it to us without contamination. The head of the sampler has a shape similar to a drill bit in order to deep holes and to collect samples, and it is opened when the head rotates counterclockwise while the motor spins clockwise. The soil sampling test was conducted on loose soil, and we confirmed the performance of the soil sampling system. For scientific analysis of Martian soil, we use temperature, humidity sensor, pH sensor, salinity, and pH sensor to measure meaningful online data about water and life, using the returned soil samples from the rover. Long-distance remote communication is very important to complete all the missions. So we use commercial RF modem to transfer rover data to the control room. The maximum transmission length is 2 km. We can confirm the rover status and current position from the data using graphic user interface and visual information. In the GUI, the yellow circle is the rover, and it indicates heading angle and position on the map in real time.